welcome to our channel EU Physics, Easy Understanding of Physics. This is our first video. As the beginning, in this class we are going to discuss the chapter Gravitation of class 9 CBSE. Hope you will enjoy the class, and if the class is helpful, please do subscribe my channel and press the bell button also for further notifications. We are starting with gravitational force. We always observe that if it drops something from a height, it will fall towards Earth. We also know that all planets revolving around Sun. Similarly, the Moon revolves around Earth. In all these cases, a force must be acting on the object. And Newton grasped that the same force is responsible for all these cases, and that force is the gravitational force. Now, then what is gravitation? Gravitation is the phenomenon of attraction due to masses. The two terms, attraction as well as masses, are very important in this section, because in the case of magnet and charge, we are considering both attraction as well as repulsion. But in the case of gravitation, we are considering attraction only due to masses. And the first and the important topic in this chapter is the universal law of gravitation by Newton. Then consider two bodies A and B separated by a distance D. Okay, the mass of A is m and the mass of B is small m. Now we have to find out the force of attraction between these two bodies. Okay, this force is directly proportional to the product of their masses m and m, and this force is inversely proportional to the square of the distance between them. In order to show the inverse proportionality, we are writing it as 1 by d square. While combining these two, we will get f is proportional to m divided by d square. Now we have to change this proportionality by a constant, that is f is equal to g m divided by d square. What is this g? Here this g is the proportionality constant and is called universal gravitational constant. Clear? And the accepted value of this g is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Okay, this is our equation for universal law of gravitation. F is equal to g mm divided by d square. In statement, we can state that in every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Clear? Okay. Now what happens if the mass increases? This force as well as the mass are in direct proportionality. So if the mass increases, then of course the force also will increase. And what happens if we increases the distance? Since they are in inverse proportionality, if the distance increases, then force will decrease. For example, these two masses. Here the distance between these two objects D is very small, but the force of attraction F is high. What happens if we separate these two bodies with a higher distance? Here distance D is far. Distance two bodies are far means the force of attraction will reduce. Clear? Okay, this is the important point, the universal law of gravitation. Then we can check how this unit of G, Newton meter square per kilogram square, how we arrived this unit. From this equation, we can write G as, what is G? F into d square divided by m into m. In order to find the unit, what is F? F is force. The unit of force is Newton. And what is D? D is the length. The unit of length is meter. Since we have this d square here, we can write it as meter square divided by this. Both are mass. The unit of mass is kilogram. Since we have two masses, we can write it as Newton meter square per kilogram square. This is all about the universal law of gravitation by Newton. Now, we learned that Earth attracts every object towards it. It is due to the gravitational force. Whenever an object is falling under the influence of this gravitational force alone, then we can say that the object is in free fall. That is, there is no influence of any other force. Only due to this gravitational force, if the object is falling towards Earth, then we can say that the object is in free fall. And during this fall, there is no change in the direction of motion of the object. But the magnitude of velocity will be changed due to the attraction of Earth. And we know that every change in the velocity involves an acceleration. Here the acceleration is due to the gravitational force of Earth. Hence, we can call that acceleration as acceleration due to gravity and is denoted by g. G is the acceleration due to gravity. And now, from your previous chapter, that is force and laws of motion, you already studied the second law of motion by Newton. What is Newton's second law? Newton's second law is force is the product of mass and acceleration. What is here the acceleration? Here our acceleration is acceleration due to gravity. So we can write it as F is equal to mg. And from the universal law of gravitation, we already arrived an expression for force. F is equal to gmm divided by d square. Here we can replace this F by this. So we can write it as mg is equal to g m divided by d square. Now we can cancel this m here and here. Now we got an expression for g as g is equal to g m divided by d square. What is m here? This capital M is the mass of Earth. And what is d? D is the distance between Earth and the object. Now, what happens if our object is on or near to the surface of Earth? Suppose this is our Earth and our object is here, on or very near to the surface of Earth. Then what is, this is our D, right? Then what is this D? D is nothing but the radius of Earth. If so, we can replace this equation as G is equal to gm divided by r square, which is the radius of Earth. This is applicable only if our object is on or near the surface of Earth. If the object is very far away from the surface of Earth, then we can use this equation, that is gm by d square. Now we have to find a value for this acceleration due to gravity. For that, what is g? G is actually 6.673 into 10 raised to minus 11. While rounding, we get 6.7 into 10 raised to minus 11 Newton meter square per kilogram square into what is mass of Earth. The mass of Earth is 6 into 10 raised to 24 kilogram divided by radius square. We will get 6.4 into 10 raised to 6 meter. While substituting all these values, we will get G is equal to 9.8 meter per second square. Acceleration due to is same as that of acceleration. The unit is same as that of acceleration, that is meter per second square. This is the value of acceleration due to gravity G.